There are a lot of technicalities about graph searching. The two big graph searching strategies or algorithms are breadth first search and depth first search. As a first pass on each of those, breadth first is you start at a node and you look at all the ones that you can reach in one step. And then from each of those, you look at all the ones that you can reach in one step, which are now two steps from where you started. And then all of those. So you look at all the ones on level one, all the ones on level two, so forth and so on. In depth first, you start at a node and you go to a node and then you go to one of its nodes and then you go to one of its nodes. And when you run out, you come back and start over again. So breadth first or depth first, those are the two most common strategies. And there's an algorithm in our textbook, it's algorithm 9.3.8, and it talks about how to do breadth first search. And it's a little bit more confusing than it needs to be, I believe, because it contains a lot of the details of the implementation. And so it's more focused on the implementation than on the algorithm. And one way to not understand an algorithm is to be so focused on the implementation that you don't know what the algorithm's trying to say. So what I'm going to do is illustrate that algorithm without so many of the implementation details, just to illustrate what's gone on. And it's pretty clear what's going on. And so that's the situation. So this is breadth first search. So let me write that down. And it's algorithm 9.3.8. So that's what we're aiming at. And I have drawn a graph here for us to practice on. Now, this is a cartoon of that graph of Amazon business concepts. And so that's just to help reinforce the idea that not almost everything, but so many things can be represented by graphs, and so you need to know what's going on. And so what we're going to do is go through this graph. It's a little bit long, so we might stop before we get to the end, but at least when we get to the illustrating all the main points. We're going to go through this graph and find everything that's in there and find how far it is and how to get to that node in the graph from the start. So the start is, and this is based on that original Amazon picture, is the node I've labeled MB here. I think that stood for more buyers. So that sounds like something that Amazon would like to have. So we're going to start with more buyers. I guess they want to end with more buyers, but that's more of a metaphor kind of thing. So we're going to start with more buyers. And what we need to do is look out for the following situation. So I'm going to look ahead a little bit. So if I start with more buyers, I get to this FC, I think that was fixed costs. And fixed costs lead to LP, that's lower prices. And lower prices need to go to more buyers. So if I start doing a breadth first search for more buyers, I'll go to this node and this node. I'll come back and mark those in a second. And then I'm going to come to this node, and that's the only way to get out of this, I guess it's FC. And then we're going to get back to more buyers. Well, now we've gone in a cycle, and so that's just going to put us in an infinite loop. I call that a data loop. It's a loop in the data, but is nonetheless a loop. It will nonetheless chew up all the resources in the universe, and so we need to avoid that. And the way we avoid that is when we have visited a node, we mark it as visited. In the algorithm in the textbook, they have a field within a class basically called visited that's a Boolean, true or false. And so everything starts off with visited being false, and as you reach that node doing the various manipulations in the algorithm, you say, oh wait, I'm at this node, so you mark that to be true. And so that is right in the middle of step 4 of their algorithm. So this is a copy of their algorithm. And let me just say, okay, we've reached this one, so that's what this arrow indicates. So that says, okay, now we've reached this one. So next time around, that if we go around a loop and come back to this, we'll say, oh, we already got here. So that's what's going on there. Graphically, and I'm kind of down on graphical things because they're very difficult to handle when you have a large amount of data, but they're also a good way to illustrate what's going on. So graphically, the way that we're going to do that is as we go through this graph and as we visit nodes, we're going to write a number, and the number is what level we're at. And if we come to a node that has a number, then we know it's been visited. So that has the same effect of having a different field in the class called visited or something. We are doing a little bit of inference in order to do that. Now, that kind of inference was much more common in the early days of computer science than it is now, because now we have the concept of a class, which took a while to invent. It's almost embarrassing. Anyway, we have the concept of a class, and so we can have a Boolean field in a class, and so we don't have to do a little bit of computing to say, oh, look, there's a number there. So we found that one. So we can save ourselves a computing step by using more space. That's always the trade-off in computer science, right? You can save steps by using more space, or you can save space by using more steps. So this is just an example of that. Okay, so this is a smaller picture, but I think it's big enough for us to do what we need to do. And so what we're going to do is start off at the node I've called MB on this, which stands for more buyers. It might stand for microbiology and that this is some list of majors at some university or something. Anyway, so I'm going to label that node 0. That's our start node. It's a little bit small, but you can see I've said there's 0. And by hook or by crook, I'm going to look at all of the edges that go out from that node. And so that's very much implementation dependent of how you're implementing the graph. If you have an adjacency matrix, you're going down a row and looking for the ones. And if you have an adjacency list, then you're going down the list and doing that. And so you get too tied up in the implementation details and you won't see what it is that you're really trying to do. So let's see what it is that we're really trying to do. Okay, so we start at this node that's kind of in the center here. I've labeled it 0. And if I'm reading this correctly, there are 2 edges that go out from that node. So I'm going to label each of them 1. And if we were doing this in some kind of coding or even pseudocode operation, we'd have to have some method of deciding what order to look at the things. But if it's a matrix, you just go down the row and say this one, no, not this one, this one. Or if it's an adjacency list, you say, oh yeah, these are the ones, and you go down the list in whatever order it happens to be in. So here I'll try to go top to bottom. So that was level 0. These are level 1. And now at each node that has level 1, I'm going to look at all of its out edges. So from FC, I only have 1 out edge. That goes to LP, that's number 2. And from MS, I only have 1 out edge, and that goes to BS, which I think was better service or something. Now I don't remember. Anyway, so I had level 0. These are all the things that are 1 step away from level 1, and now these are the things that are from level 0. These are the things that are 2 steps away from level 0. And we've guaranteed that those are 2 steps away. It's not like we missed one. We got all the ones that were 1 step away. Okay. So now again, I'll just kind of use top to bottom as an organizational scheme. At LP, at the top up here, there are 2 out nodes. And the upper one is AS. I can't remember what that stands for, but that's now labeled with 3. And the other out node goes to MB, and that's already labeled. So from number 2 up here, I can go and get to number 3, and so that's really new data. But now this one we find out has been visited, so we don't continue down that path. Okay, so that was out of LP. Out of BS, there are 2. One is to BV, that's number 3. that's numbered with 3, excuse me, I should say that. So that's at level 3. And then we can go from this BS up to AS. And so that's up here. And that's already got a number on it. So it's been visited. So that's what's going on with this visited field in the class describing nodes in the nodes. I guess they say vertices in the book. Okay. And then, well, now we look at all the level 3 things. That consists of BV and AS. And AS is the upper one. So using the heuristic, we're going to go down to, that got smudged. I think that's SB maybe, I don't know. Anyway, that's at level 4. And the other, that's the only out edge coming from AS. And then from BV, there's only one out edge, and that goes back to where we started at MB. And so that's it. We have labeled all of the vertices or nodes in the graph, and so that completes the depth first search. What that does, though, is that gives us a path from the starting point to any place in the graph. And so, and again, it depends on your implementation as to how you want to store that, manipulate it, so forth and so on. In the algorithm in the textbook, what they do is they put these things into a stack. So that means the last one in is the first one out. So as you add things, the stack gets deeper and deeper. So the first node that you visited is way down here. The last node that you visited is up here. So you go through this, you need the stack to reverse the order. They describe that in the textbook. But basically, that is the breadth first search algorithm with one way of looking at it. Is if you follow through on something like this while you read the algorithm in the textbook, the algorithm will make much more sense, and then you can worry about specifics of implementation. By the way, when I was preparing this, I was going through some of my old books, and I found an implementation of depth first search in the programming language that you may have never even heard of, Pascal. And so in the 1980s, Pascal was the standard teaching language in computer science programs. Everybody learned Pascal. It had pluses and minuses and other operations as well. No, I'm just joking. Yeah. And so it was a standard for a long time. Now it's gone. And so this thing can happen, all kinds of things. That's why in computer science courses we tend to focus on the principles and the theory before we worry about the implementation, because the implementation aspects in 10 years, they'll be gone. But for the moment, we've got breadth first search, and it's a pretty simple algorithm, but it's very effective. And as you see from the book, it can be done in a nice, you could code it up based on the pseudocode that's there. And so there you go.